Welcome. Today we're going to be working on an easy one. Problem 1304. Find n unique integers that sum up to 0. So let's get started. Go over the problem like always, and we'll see what's happening. So 1304, easy problem. Given an integer n, return any array containing n unique integers such as they add up to 0. So if you get n is 5, you need to return an array with 5 elements that equals 0. So if you sum up -7 minus 1, that's -8, plus 4 plus 3, 7, 8, 0. -6, 6, easy enough. The constraints. 1 is less than or equal to an n, which is less than or equal to 1,000. So one thing I really want to highlight on this is whenever you have a LeetCode problem, you want to break it down. And the constraints are usually a hint on edge cases or on problematic areas that you might not account for. So when you see the fact that this says the constraints are 1 to n to 1,000, you need to make note of that because it will come up. And it looks like here, a negative integer and a positive integer are both counted as unique. So the best way to go about, I would go about solving this is each integer has a negative counterpart. So for instance, the number 5, if you add a -5 to that, it equals 0. So we can go through about that for any time that n is equal to an even number. We can always even the array out by just giving the opposing inverse value. If n is odd, we'll even out with the first 4, and the next one will be odd man out, which will mess it up. And that's where you get into reading the problem well. You can use the 0 here, as you see. That's a use case. So let's make note. In this case with 3, an odd number, they're doing the exact strategy, -1, 1, and a 0 to balance out. So let's get to starting. So we're going to first start with the edge case. N equals 1. If n equals 1, return new int with a 0. And we're doing this first because we want to save the run through of the code. If you perform these edge case calculations and checks first, then we'll hit them before we have to navigate through the code, which will increase our runtime and also save on memory. And now we'll just get to the actual work. Create a new integer of the size of n, as we need. So check and see if n is even or odd, because we can negate it if it's even quite easily. And if it's odd, then we would want to negate it and then add another element, a 0, to accommodate for that extra number there, if that makes sense. So we'll create a Boolean. Is n even? We'll assign that to n modulus 2 equals 0, because if you remember, this gives you the remainder. The remainder divided by 2 is 0, then it is an even number. And we're just going to give a random counter here. I'll start it at 2. It's because I don't want to start at 0. And we're going to use this counter variable will pretty much be the start of what we assign the unique array integers. We're going to start a for loop here. And then if I is even, then we will add a unique positive number. And then if it's odd, we'll do a negative. And then otherwise, if it's not, and it's odd, so we'll do the negative. So -1 times the counter, and then we're going to increment the counter here because we need to have a unique element. So we'll assign the positive number 2. Then the next iteration, we assign the negative number, -1 times 2. Then we increment counter. So the next time it goes through, it'll be 3. And then it'll be -3, 4, etc. This way we have unique integers coming through. This is a post increment operator, so it adds a +1 after the usage of the variable in the expression. Okay, that makes sense. And now we need to account for if it's odd. So in a use case here, let's think about this. Let's think if I had n equals 3. So once we iterate through the loop here, we will go 3 iterations to this for loop. 0 array, zero array would equal 2, -2, and 3. So that is incorrect. So what we're going to do is we'll add a simple check here at the end. If n isn't even, then we're going to assign the last element 0. Then we'll return it. That way, we loop through, n is odd, so we will replace this with a 0. Now we have -2, or 2 plus -2 equals 0 plus 0 equals 0. Let's run it. Oh, forgot a semicolon. It's accepted. Let's submit it. All right, and the complexity is beat. So just to go over some of the points for this problem, you want to iterate over it once. That's why we're handling the odd n use case at the end. And you want to account for the edge cases in the beginning of code. Because when you see an edge case, if you can calculate that and return the answer as quick as possible before running through any logical code, so by hitting this edge case here, we aren't having to run through all this code and then return the edge case if we had it down here, for instance. So it saves in efficiency and gets things going faster. I hope it was helpful. Good luck and keep on keeping on.